Hello everyone, my name is Vasudev. I am the Product Marketing Manager for the Power Solutions in the Tektronix Scope product line. Today we are going to talk about the new capabilities we have added into our automated power measurement solution, and particularly we'll talk about the Bode Plot capability. Control loop response, or Bode Plot as it is popularly known, is very critical for power design engineers who are keen on assessing the stability of their closed loop response system. This is very important as the customers look at optimization of their design. Control loop response, or Bode Plot, is basically in need of a stimulus which will be swept from a start to stop frequency, and using an isolation transformer the signals are injected. And the way we do it in our Tektronix solution, the 5 series or the 6 series MSO, is taking advantage of our optional AFG functionality. We inject the desired signal using this AFG through an commercially available isolation transformer, as you can see here. And here is an example of a LDO demo board where the injection from the AFG is made through the isolation transformer. A quick video here to take you through the actual setup. This is the Picotest commercially available isolation transformer. You have got various models based on the frequency of need. Right now for this we are using a 45 megahertz capable isolation transformer, which is connected to the optional AFG output which is available at the backside of our 5 series or 6 series MSO. The output of the isolation or injection transformer is then fed into the device under test. Here is an LDO, and typically this is injected through a low resistance injection so that it does not, the injection resistance does not impede the circuitry. The LDO demo board, what we are using here, is powered using a Keithley power supply, and the input and the output of this LDO is then fed into the oscilloscope using the TPP0502 probes, which are the ideal choice of probes for the frequency response analysis. As you can see, the probes are automatically detected by the oscilloscope, and you can do the probe compensation. And once you go into the measurement power tab, as you notice, we have added the new capability of control loop response and power supply rejection ratio. You can also add the results table to ensure that we get all the details as the performance is run through. And once you go into the configure, you can set up the impedance of interest, the points per decade, the start and stop frequency, whether it is constant amplitude or amplitude profile. And once you press the preset, the software automatically enables the AFG, as you can see at the bottom there, and test is started with the frequency being swept from the start to stop frequency at the desired amplitude. As you can see, the plot is frequency versus gain on one side and frequency versus phase on the other side. So it is a three-way plot which is rendered as the input and output are measured, and the phase and gain plots are taken through. As soon as the gain crosses 0 dB, the software automatically calculates the phase margin, which at this point of time shows 45.94 degrees at 6.377 kilohertz. The software continues to perform the test, takes you through the various frequencies that you have selected, and then as the phase plot crosses the 0 degree, you will see the gain margin automatically calculated. So the critical two measurements from the designer point of view is the phase margin and the gain margin. The other thing you would notice here is, as the frequency is swept, since we have selected constant amplitude, it's at 100 millivolt, but like I told earlier, we have the ability to have amplitude profile. So the software detected the crossover of the 0 degree phase and looked at what the gain is, and the gain margin is now tabulated in the results badge at 42.88 dB at 195.7 kilohertz. The software continues to sweep through till the stop frequency, and as you can see, the results table is getting added with the various points of interest with the respective frequency, gain and phase. So Bode Plot capability is now made possible using the oscilloscope, taking away the need for a standalone frequency response analyzer or a vector network analyzer, thereby makes the life of the design engineer that much more easy because the same oscilloscope is used. You can invoke the markers to look at how the phase and gain values are at each of the plot points, so it's very detailed capability. And you can see that at T2 crossovers the same thing is captured in the results table. You can also capture all this in the form of a report format, and you can go to File, Save As, and say Report, and you should be able to get a PDF report which captures all the details of the setup, including the screenshot of the plot, making it a comprehensive solution. If you need further details on the Bode Plot PSR or capabilities, please do get in touch with your local sales team or contact myself, Vasudev UN, or my colleague Gajendra Patro. Thank you very much.
Find out more at Vicom's website.